Do you have like a review?
Oh yeah, I have like you know that like that website we used last time
Oh,
for
that's right.
like
That's right.
so I got the same thing, but this time the test is only on like one unit, so we
Which
might
one?
finish it like it's on unit 4.
Sorry, I don't know. I don't
Oh,
know.
it's like solubility rules, net ionic
Okay, okay.
equations,
Got it,
acids,
got it, got
yeah.
it. All right.
Okay.
I see.
Oh, okay. Hold on, let me share screen.
Okay.
Okay.
I'm
So,
gonna have to start to see the problems because I've practically forgotten. That's
oh
okay.
yeah. Okay. So, there's this.
Which one of the reactions is a reaction in which the same reactant undergoes both oxidation and reduction? Okay.
Wait, how
Um,
does that work?
yeah, I don't know. I guess you would have to have something broken up into something else.
Oh.
Let's see. That's what I would think. I don't know. Um,
Oh, okay, I see.
what
So,
is that? Selenium, some sort of selenium acid. I don't know what you would call that acid up there in the
yeah. So I
H2SEO.
think that I looked through all of them like really quickly, and the only one
Mm-hmm.
that looks like it's like splitting up is this one, right? Because it goes from
Gaining electrons, right? And
yeah,
then
and then over here it loses electrons because it has a negative charge and O is negative. So I think, right?
sorry, remind me when you have 3Br2, the oxidation state is 0, or is it?
Yeah, it's 0.
Oh, you call it 0. Okay, I forgot the oxidation rules. Okay, yeah, I think that seems right to me.
Because I don't think anywhere else there's like a reactant that could go both undergo
And then
both
since you
oxidation
have
and
bromate, you have the bromate ion there, BrO3 minus.
yeah.
That's O would be the 2 minus, right? And then 3 times 2
Yeah.
minus is 6 minus.
So it would have to be like +5 on the BR here because O3 would be
Yes.
negative
Yeah,
6,
yeah, yeah. Yep.
and then this would just be 1
Okay.
minus. Or I guess, wait, would it be 1 minus, or since it's times 5, would it be?
Oh, I
I
forgot. I'm
guess,
sorry. I think it's
wait, no,
1
I
minus.
guess, well, I think because it is 1 minus on this like 1 BR minus, but I think
The
like
net,
total,
you're right. The
yeah,
net, if you're gonna write out what are they, half reactions? I forgot. Half reactions or something, then you would do
yeah,
5 electrons. Yeah.
yeah. So C, I would think, okay, yeah,
Yeah. Good.
to um to balance. Oh, this is a half reaction. Okay. So what's the charge right now? So -4, and then because OH minus times 4,
Yeah.
and then this is just 1 minus.
So that's -5 on the left side.
This is 2 minus, and then this should just be 0.
0.
So
3?
this was, yeah, 3 electrons on the right side, I think. So B, yeah.
Good.
Okay. So which
Which is
contains the element
reduced in the
reduced?
reaction. Reduction is gaining electrons. Okay.
Yeah, reduction is
So
gaining electrons.
so is if H2O was gaining electrons, it would become okay. MnO4 is being oxidized, right? No, 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 no.
Isn't
It is, right?
Mn? Oh wait, no. I think Mn is being reduced.
But it's asking about the whole species, right? Not
It says
just the.
which contains the element. Like
Oh, okay,
wait, one
okay,
minute.
okay. Got it, got it.
Okay. So which contains the element that is reduced? So I think it's actually it might be this one, right? Because over here it should have a positive charge to like counteract the O, but then here it's neutral, so it should
Okay,
have.
sorry, just to confirm. So just to be precise with this, the
Wait, I'm not
O4.
sure. Wait, never
Okay,
mind.
okay. So O4 right now, that would have I guess so each O is 2 minus
Fine.
times the 4 is 8 minus, and then Mn would be 7 plus.
Yes.
Okay. But then you have to
So
multiply by
then,
4 because there's four molecules, or I guess 4 ions of that, right?
but I mean over here it's 4 anyway, so you can just like.
Oh, okay, that's right.
So this is
So
+7 here, and then over
yeah,
here since it's O2, so it's
4
-4,
plus.
so it's 4 plus, so that
That
would
means
be
it gained
D.
electrons.
Okay, so it would be D, right? I think.
I would think
Yeah.
so. Yeah. Okay.
Okay. Okay.
You know, multiple choice is harder than free response.
Really? I don't know.
Yeah.
I can't decide.
When the equation above is balanced and all coefficients are reduced to their lowest one over terms of okay. Well, we start off by balancing probably. Okay, I would have to do this on paper. Maybe we can annotate. Maybe that might be the better way to do it.
Oh yeah, let me see. Are you allowed to annotate?
Is this working? I think it's.
Oh yeah, it's working.
Okay.
Yeah.
So I would put 10 there for the carbon.
Yeah.
For the hydrogen, I would put 6 here. S, we have 1. Okay. So now let's balance the oxygens and see. Obviously, they won't be balanced, so we'll have to do some back and forth. But let's see. 10 times 2, 20. 6 times once. Okay, we have 20, 26, 28. We have 28 oxygens on the right side. Okay, hold on. You have 28 oxygens on the right side, right?
Oh my god, the echo is so bad. I think there's a better way to do it, but it's more complicated. And he said that we wouldn't need to do this on the test. So should we?
Okay, sorry. Can I just finish this just because I'm like almost finished? Okay,
yeah.
So 4 and then 24. So I guess this would be 12. So the coefficient for O2 should be 12 if I balance this properly. Can you check? See?
Oh, yeah, sure. You're correct. Good job.
Good. Okay.
Okay. Which of the following is a redox reaction? Okay, so is there a way to, like, this one has charges, right? And none of the other ones have charges.
So I remember something is if you have a double replacement reaction, usually it's not a redox, right? Because it's just being replaced.
Okay.
If you have a single replacement reaction, it must be redox, right? Single replacement.
So like an element becoming like part of a compound, or a compound like splitting into an element, right? Into elements.
I think so.
Okay.
So let's take A for example. Did you want to look at C?
I was looking at like D, but I wasn't sure.
Okay.
Because it looks like H is
well, H doesn't change because you have 2 plus there, and then you have 2 plus 2 minus there. Oxygen, I don't think oxygen changes either. So no, I don't think the last one is. Huh?
Because B. So I was saying is it not B because B is.
I don't think so because it's a double replacement. Meaning, if it's a double replacement, the charges are essentially, I guess, oxidation states are essentially the same, right?
Yeah.
Yeah, that shouldn't be a redox. So it's either A or C.
Yeah. Okay.
Let's look at C real quick because I just feel like that might be easier. Barium is what? Oh God, 2 plus? I don't remember. I think it's 2 plus, right?
Do you want me to open it? Okay.
I'm pretty sure barium is 2 plus. Let me check. Yes, 2 plus.
For the dark mode.
I prefer dark mode too.
Okay.
2 plus, yeah.
2 plus.
So barium is staying 2 plus because CO3 is 2 minus, right? Carbonate ion is 2 minus.
Yeah.
So oxygen is 2 minus, 2 times 3 is 6 minus. That means carbon is 4 plus 2 minus. Yeah, so that's not, there's no net, like there's no.
So would it be A then?
It would be A, but let's just confirm you calculating oxidation states. So O on this side would be what? 2 minus times the 3 would be 6 minus. Cl would be minus. K would be plus, right?
Yeah.
Oh God. So net, because there's 2, this would be 2 plus, 2 minus. Am I doing this right? I don't think I'm doing this right. Because it's chloride is an ion, right? ClO3 minus.
Yeah.
I see. So this should be 2 minus.
So this is just 2 plus the K.
So what is Cl? 2 minus. So Cl should be 1 plus then, right?
Yeah. Wait. Yeah. No, isn't it
Because
1 minus?
Cl is 1 minus, but the thing is, ClO3 as a whole is an ion, the chloride ion, and this is ClO3 minus, right? So if
Yeah.
O is 2 minus, 2 times 3 is 6 minus, then this should be 5 plus. I'm sorry.
Oh, okay. Okay.
Right? Is that right? Tell me if I'm
Yeah.
wrong, because I might be wrong. So
I
then
think
that would be
that's
5
the
plus.
case. Okay.
5 minus 2 is 3. Okay,
Isn't
so
it
then
just
K is still just plus. K is still just 1
Yeah.
plus.
Yeah. Okay.
That seems wrong. I don't know. No,
Well,
that's right.
it's
That's right. That's right. That's right.
okay.
Okay, I'm sorry. Okay. So
Okay.
just to make this a little bit cleaner. If we have KClO3, this is the chloride ion, ClO3 minus, and then K plus, right? K plus on its own is just 1 plus. Now the O
Yeah.
on its own would have a 2 minus, but since we have 3, we have 6 minus. To get the net minus charge, chlorine would have to be 5, or not 5 plus. Yes, 5 plus, right? Because 6 minus plus 5 is just minus.
Okay. And then I
So,
also think
mhm.
oxygen would be oxidized. Is that the case or no? Does that
Oxygen.
happen?
Well, we know for sure the chlorine is definitely changing,
Yeah,
right?
but I think the chlorine is reduced
Chlorine, is the chlorine reduced or is it oxidized?
because the charge on this was +5, and then I think it's going to
But wouldn't
negative
it
charge
be
here.
okay, +5 and then it would go to -1? So yes, it
Yeah.
would be reduced. So then the oxygen is oxidized.
Yeah, I think so. I mean,
I don't know if
I
that
think
makes sense, but
I
okay.
think K stays the same actually because it was
K stays the
+1
same. You're
here.
right.
Yeah,
Absolutely.
okay.
Yeah.
So I think it's A, yeah.
A.
Okay.
Okay.
So
So
okay.
hydrosulfuric acid, is that what that's no, that's not that's just sulfuric acid, right?
Yeah.
Okay.
I guess.
Yes.
Um,
So SO4
uh,
is 2 minus or what? Is that right?
I think
Yes,
maybe
because H2, H is 1 plus and yeah, 2 plus. So SO4 as in polyatomic ion would have to be 2 minus.
okay. So in this one, so it would be -8, so this would be +6.
Yes.
Okay, yeah. So we're just trying to find where else it has +6.
Yeah.
So obviously not here, it's 2 minus
Yeah.
on its own.
That would
This would be -6 +4, or
divide by
like +2
2. So
+2
plus
on
2.
its own. And then this would be so SO3 has a charge of 1 minus.
I'm sorry, I do not remember. I think so. Let me search it up. Sulfate ion. I think SO3 is sulfite. So SO4 is 2 minus. So SO3 must be the sulfite ion, which is just 1 minus. Yeah.
Okay, so this would be
Plus 5, right?
yeah, +5. So I
So
guess it has to be A, but let's check. So -4 and then +2.
-2, right?
Oh yeah, sorry.
And then
Yeah,
plus
so
6.
yeah, okay.
Yeah, so
A.
it is A.
Okay.
Wow. These make you think.
Yeah, it's good practice though. I mean, not for you. It doesn't matter for you.
No, it's just a good, exercise of the mind.
Okay. Which represents a redox reaction?
Not the first one. The first one's double replacement. Or no,
Yeah. Well, it's
that's not
just
double replacement. It's just a combination, right?
it's
What
like
is that?
a synthesis. I don't know.
Synthesis. Yes. Yeah, synthesis. Yeah.
Okay.
So which ones, can we rule out any that are double replacement? They just make it easier to work with, I think.
Yeah, let's see.
I think D would have to be double oxidation, right? A reduction reaction. Because you have a lone element here.
Oh yeah, you're right.
Then it's being incorporated into something else, so it must have a oxidation.
So this is oxidized right here because it goes from 0 to a positive charge.
To positive charge, yep. So
yeah, and then
oh, sorry.
I guess SO4 wouldn't.
Oh, so you're saying, okay, so if Cu is oxidized, something else had to be reduced, right?
Yeah, I guess S could be reduced, right? Because
SO4 was 2 minus.
So it would be +6 here in this one.
Yep.
And then over here it has to be +4.
+4, but then you have to also remember there's an S here.
Oh, right.
Are you trying to figure out what got reduced?
Yeah.
Could it be the oxygen that got reduced? Or does that not happen?
The oxygen is so split though, right?
Does that, I mean, okay, so let's just see. So if copper gets oxidized, something had to get reduced. So let's look at the hydrogen real quick. So H2, this would be 2 plus, times the 2 would be 4 plus, and then this would also be 4 plus. So hydrogen stays the same.
So the S can't have been what got reduced?
So S can be reduced. I don't know if we've done it properly. So SO4 is 2 minus, 8 minus, like you said, that's 6 plus, right?
Yeah.
But then you have to take the times 2 into account, so that's 12 plus.
But then there's one over here, like one of the
that would still be 6 plus, right? That's 6 plus?
Yeah.
Because SO4 is 2 minus, yes, 6 plus. And
then over here it's 4 plus.
4 minus, 4 plus. So we had to gain electrons. So this is a net 10 charge, yes.
So
we have to
it was
so sulfur
reduced.
is, yeah.
Okay, so it's D. Okay. How many milliliters? Okay.
Oh God, I can't solve these problems. I don't think I can.
Don't you just need like double? Wait, am I just misunderstanding?
How many?
Not double. Not I thought it was 16. It's not double. It's wow, I'm just blanking. It's what's the word? I don't know. It's not it doesn't go from 8 to 16. It goes from 8 to 1.6, but it's like proportional, right?
Oh, so it's
divided by 5. Yeah, okay.
So it's times 2 divided by 5, right? No, it's times 2 divided by 10. So yes, divided by 5. Yeah.
Yeah. So if it's divided by 5, then you need 1/5 the amount of milliliters as well to get the same amount of moles, right?
Don't ask me on this one.
I think it's 30 actually. I think so. Because you need the same amount of moles, but you have different molarities. So, and since this is 1/5 the molarity, and they're using this much to get
okay, if we were to do this with precise math, you would have 8 moles HCl per liter, and you're gonna multiply
you can just use a proportion. It just has to be equal the same. So like 150 times or like 0.15.
Oh, okay, I see what you're saying. So I see what you're saying. Okay. Go ahead.
So you just have to have the same amount of moles everywhere. So moles is
0.15 times 1.6, right?
Yeah, moles is molarity times volume. So you just do 0.15 liters times 1.6 and then equals 8 times you know, this
I
amount
see.
of,
Perfect.
and then
Perfect.
so
Okay, I got it.
you just solve the proportion, and I think you'll get 30. Yeah. Okay.
Yeah, exactly. Because 8 divide or 24 divided by 8 is 3, so it has to, yeah, and then you can move around your decimal.
Okay. What volume will just react with 0.424 grams? Okay, we need the periodic table for this, I think. Okay. Should I switch?
Go ahead. Yeah, that's fine.
Okay, so it says 0.424 grams BaOH2. Okay, so let me see.
Barium is, I think, 137. Yeah, 137.33.
So I think the molar mass should be 169.65, right?
What were the other ones? I forgot.
Oh, oxygen is 16 and hydrogen is 1.
And it was BaOH2, right?
Yeah.
So 16, 17 times 2, 34. So you add these together. And what did you say it was?
Did I do it wrong? I got 169 point. Why did that happen?
That's 16.
Oh, I guess it's 171. I don't know what happened, but
17
right?
34. I think I'm doing this right?
Yeah.
171.33 or
Yes.
171 doesn't. You can be as 171 usually suffices.
So yeah, 171 basically.
Okay. 171. Okay.
So 0.424. Let's see.
24.
So it's like 0.0025 moles.
What did you do again? So you had this many grams
Yeah,
per
so
mole?
I divided it by the molar mass.
Oh, that's right. Okay, because you grams times.
Yeah.
Okay, got it.
Right. So I got like 0.0025 moles. So we need twice that because the mole ratio is like 2 to 1. So we need 0.005 moles of HCl. So molarity is again moles per liter.
Yep.
So
so we do 0.005
over
over
0.13.
the molarity. Yeah. Yep.
Okay.
Neha, I don't know how you do math like that. I have to in chemistry. I remember I have to write everything out. Like I can't. I have to like cancel units and stuff. I can't do this in my head.
I'm really bad at that. I just want to do it in my calculator. I don't write anything down. It's a problem.
No, I think for the multiple choice, your strategy is a good one because you don't have time. I think.
Well,
Okay. Well, I got 38.1.
Yeah, I got that as well. So I think it's A. Okay. Yep. Nice. Okay. Wow, this is very small and faint.
Ooh, the equation. Go ahead.
It's fine. So it's the net ionic equation. I don't really know what this like is testing us on. Like, I don't know. I don't think we've done a question like this.
Well, if you've done solutions, you probably it's essentially just taking your it might be this one. I don't know though. C maybe plus NaOH. Never mind. That wouldn't make sense. So what you would do is you would just break things up into their so if this is producing what would this produce?
So how do you tell what's like the element, the other element? Like over here, it's okay.
So here's the thing. I know for how do you do these? Okay, so I know. Okay, so I know how to do it the other way around. So, but let's see. I guess what you're doing here is you're looking for something with H2. You're looking for something with H plus inside of it, essentially, and you're looking for another element with CO3 2 minus inside of it. So potentially A.
So
A might be a potential, because then what would happen is if this were our reactants HCl plus CaCO3, CaCO3, what that would yield is HCO3, right? Plus CaCl2. I don't know. No, just, is that right? CaCl2? And then that should be actually H2CO3.
but how
correct?
do you know it's not like B? It's the same thing almost except with a different element.
Well, we can check. We can check. So far this is right?
Yeah.
Okay. So then obviously you would break it up into your net ionic. So H plus Cl minus plus Ca2 plus CaCO3 2 minus. Okay, which of these becomes solid?
But isn't this a double displacement? Like, didn't you make this a double displacement?
Yes, I think that, but that's what's supposed to happen.
Oh, okay.
So yeah. So this is what happens, and then I think H2CO3 becomes aqueous, right? That's soluble. And then CaCl2 is not soluble, right? This is solid. This is where your solubility rules come in.
Oh, okay, yeah. Then
So
that
this
seems
is
right.
okay. So I think CaCl2 is solid, and then H2CO3 is aqueous. So you break it up, and then whatever's solid you don't break up because you can't break it up. So now I have 2H plus CO3 2 minus, and then of course CaCl2 as a solid. But I don't think that can be the case, because then we would have liquid. We need to have liquid as a product, and carbon dioxide as a product as well. Okay, so it can't be A then, I think.
Okay, so maybe B.
B is unlikely, because what you're actually, it is possible. Yeah, let's try B. It's definitely possible. So if you have
this is the last question, I think. So
okay.
Yeah.
Na2CO3 plus HCl, right? So what would that actually yield? That would yield H2CO3. Is that right?
Yeah.
H2CO3 plus NaCl.
NaCl.
Oh.
So okay.
So net and NaCl is soluble, so that's aqueous, and then this is also aqueous, right?
Yeah.
I don't think this would be the answer then. Right.
Do you know for sure if H2CO3 is soluble?
It's carbonic acid though, right?
Oh yeah.
So acids are soluble. Actually I don't know. I honestly don't know. That's a lie. Don't quote me on that. I don't think that's true.
Isn't it though? Why wouldn't it be?
It could be. It could be a gas, right? Hydrogen carbonate as a gas. I don't know. I've forgotten most of this stuff.
So I'm not sure how to do this one actually. I don't know. Like I don't know which one it is, but
So we need such a thing where H2O will be produced and CO2 will be produced. Which of these will produce CO2 and H2O? Probably this one. To produce water, we need H and OH, right?
Yeah.
Have we tried C? Could C work? I feel optimistic about that one. I don't know why.
Okay.
Let's try that one, and then if it doesn't work, we'll just look at the answer. H2CO3 plus NaOH will produce H and OH will make H2O, and then this will make sodium carbonate.
Is that NaCO3? What is that?
CO3 is 2 minus. That should be Na2CO3, right?
Yeah, but isn't it supposed to be CO2 at the end?
That's the problem. I don't know.
Should we just check the answer?
Yeah, check the answer, and then we'll search this one up online.
Oh, B.
It is B. Okay, maybe I just did the net ionic equation wrong for that, which is very likely. So if you have Na2CO3 plus HCl, what will that produce? I guess that will produce NaCl, right?
Yeah. Maybe it's not double displacement.
Then what would it be?
Because because you get H2O and then you get CO2. So H2O takes one of those O's and then CO2 plus I'm guessing NaCl. And then NaCl is aqueous, so it's not in the net ionic.
Okay, I'm gonna search this up online because I honestly I have no justification.
But do you know what I'm saying? Like NaCl's it becomes NaCl, which is aqueous,
Okay.
so it's not and then H2O, right?
But why would it just happen to become maybe I'm so sorry. This was okay. I forgot about this. You're right. But what happens is I guess yes, NaCl does that, but then you also have H2CO3. And then the thing is, if this is a gas, I believe, I might be wrong, but I think H2CO3 can decompose into CO2 and H2O. Or that's
like another equation? Wow, that was really loud.
That happens. I think that happens. And that's why. And then the NaCl's will cancel from the net ionic. So then you'll essentially be left with I guess once you balance this, you'll be left with 2H plus, and then CO3 minus, 2 minus, sorry. Wait. Yeah, it's carbonate 2 minus? Maybe. I don't know. I just forgot. CO3 2 minus, and then that'll produce hydrogen carbonate in the form of, I guess that'll be produced in the form of a gas or something. No, it is actually aqueous, I think.
But are you saying it'll be further converted into this?
No, I think it's actually this reaction, H2O and CO2 produce this.
Oh.
So which is weird. I don't know why you would continue breaking that up further. And since it's aqueous.
I think he said like strong acids or like strong molecules, they like push it the other way. So isn't H2CO3 like the stronger one here?
I don't know. Is it in the list of strong acids? I forgot. So.
Oh, is it weak? Is it a weak acid?
I don't know. It might be. I don't remember if that's strong or weak.
I'm not sure either.
Okay. Let me search this problem up online and see what I can find, because I'm sure someone has solved this problem online. But it's not good to be sure of anything. Anyways, this is no CO2. Oh, sorry. Liquid plus CO2 gas is the net ionic equation for the reaction of an aqueous mixture of. Okay, I found this Yahoo Answers page. I don't know if this has the solution. Okay. So this is what the answer says. Acid reacting with a carbonate is one of those reactions you just learn produces a gas.
Oh.
Okay, so this is not aqueous, and this is actually in its gas form, I think.
Interesting.
So HCl disassociates because it's a strong acid. So that we know. We knew that would dissociate because it's a strong acid. And of course, Na2CO3 is a sodium salt, so that disassociates. So like we said, it's a double replacement reaction. We got this reaction right. But then the thing is, H2CO3, this is where the trick comes in. They're saying that's carbonic acid. It's not stable in a water solution in high concentrations, so it decomposes. So I was right, I guess, before. It doesn't go back up the other way. It goes down this way.
Okay.
H2CO3 is not stable in a water solution in high concentration, so it decomposes to form carbon dioxide and water. So as a result, these are your final products. And this is one of those things you just have to know. There's more. Next time when we do this, remind me to get my Barron's book. It's in the closet downstairs for old binders and books. And
We will do that.
in the Barron's book, they outlined it very nicely.
Okay, cool. So I think that's all. Yeah, so I have this too. I'll just put this in the chat. This is more like stoichiometry stuff, I think. I mean, at the top it is.
Okay.
So you can do this. I mean, I'm talking to them, so like you can do this on your own. And that's it. Very fun. All right.